All right, today we're going to talk about functions, and when we're talking about functions, we need to clearly outline exactly what we're talking about. There are three main things to kind of look at when we're talking about functions: the definition of function, and the domain, and the range. The function is basically, we're taking two sets of numbers. So we're going from set A to B, so like an x, the set of the x's, the domain, which we're going to talk about in a second, to the range y. And what has to happen for it to be a function is every A is assigned exactly 1b. Okay, so if we start to define this function as, y equals x plus 2, each x that we put in maps to exactly 1y. Well, those inputs are called the domain. The domain are the inputs to the function, and the range are the outputs of the function. Okay, so the function, the stuff that goes in is the domain, the stuff that comes out is the range. This is something that we've kind of looked at before. And as we look at domain and range, what we're going to do is we're going to determine if these relationships are functions. So relationships could be anything in math that has to deal with us, looking at a table or a graph, or maybe even just an equation. And so when we look at this, we're looking to see if there's a one-to-one correlation. Each x has exactly one y. Well, what we see is 2 goes to 11, 2 goes to 10, 3 goes to 8, 4 goes to 5, and 5 goes to 1. And the question that we're asking is, does each x have only one y? Okay, does each x have only one y? And what we do is we look at these two right here. And so that tells us that each x, in this case, doesn't have just one y. The x value 2 has two y values, so this is not a function. So that's what the table. So this table has a limited number of values, but that's going to tell us this is not a function. When we look over here at this graph, in general, we can kind of see it's sort of a parabola sort of thing. But each x along here maps to only one y. The way to say this that we use is the vertical line test. But in this case, we see that, yes, it's a function. Each x has only one y. Okay, if we had a function that looked something like this, like if the parabola was this red one here, then we could see that like x equals, 3 here would have 1, 2 values of y. But in this case, the blue one, where we had the dots, would be a function because it has, each x has only one y. As we talk about independent and dependent variables, we're looking at functions, and so if I would define y equals x squared, we would be looking at y as a function of x. Y is a function of x. I put in x equals 1, and then out spits a y. So what I put in is my independent. I'm picking that. Okay, that's kind of my x value in this case. Okay, and what comes out is my dependent. And in this case, that would be my y. It depends on what I put in. So I put in an x equals 2, a y spits out. I'm not picking that y. The y is what comes out when I put in my x. Okay, so that's the difference between independent and dependent. As we look at these, we're looking at y as a function of x, and what we need to do is we're going to solve for y, because that will tell us if each y is going to have, or each x is going to have one y. And so what I'll do is I'll subtract x squared from both sides, and I'll end up with y equals 1 minus x squared. Well, when I get that, this is a function, because each x would yield one y. There's no funny business, no pluses or minuses or anything like that. When I look over here, I'm going to solve for y again, and what I get is y squared equals 1 plus x. Well, that's great, except I want to have y by itself. So I'll take the square root of both sides, and we remember that when I'm taking the square root, when I write the square root, I've got to have that plus or minus situation. Well, because each x that I put in is going to have a plus or a minus, that means that each x has two values. Okay, in this case, it would be a plus or a minus. So if I put in 2, it would be, for example, x equals 3, y would be equal to plus or minus 1 plus 3. So I'd have y equals plus or minus root of 4, so plus or minus 2. Well, that's two values. Okay, so if I put in x equals 3, I've got plus or minus 2. That doesn't work. I can't have that. That's not a good thing. Okay, so that means that this is not a function. Okay, so look at that plus or minus situation to determine if it's a function. Function notation. Function notation talks about inputs and outputs, and so when I'm looking at function notation, I'm really looking at what is my input. So in this case, we're going to say my input is x, and my output is what I'm doing to x. So that's going to be my f of x, my function putting in x. And so my equation would be something like this. F of x equals 1 minus x squared. Okay, and so that means that what we're doing is putting in x into this function, typically defined by f, but it could be a g or it could be anything else. Okay, and so like let's say I have f of x equals 3 minus 2x. Okay, and so if I have x equals -1, I'd put f of -1, because -1 is what's going to go in for x. And that's going to be equal to 3 minus 2 times -1. So I put in whatever's in the parentheses. And so I'd end up with 3 plus 2, or 5. So therefore, this would mean that f of -1 equals 5. Okay? And so that's how that works. Whatever is in the parentheses is what goes into the function for x. So when I look at something like this, basically what I've got is, I've got g of x here. That's my function being defined in terms of x. Well, each of these x's is telling me what is going to be the thing I'm subbing in for. Okay? And so when I look at this, I've really got to look at each of these individually. What am I putting in? So in this first one, I'm going to be putting in 2. And so let's just make a sort of a blank equation to tell us where we're going to put these things in. Well, x is what they put in here for g of x. And so when I define my function, g of blank, meaning I'm not going to put anything in, I'm going to leave a blank, I've got to keep this negative sign because that's... So I've got negative here. And then I've got a blank where x went in my original function, so there's my x, and it's squared. Okay, my second element is 4 times whatever, and then plus 1. And so really, here and here and here, that's where I'm going to plug in these values that they give me in each of these examples. And so g of 2 equals negative, and then 2 goes in the parentheses, squared, plus 4 times 2 plus 1. And then I simply evaluate. So as I go down here, it's going to be negative 4 plus 8 plus 1. Really got to remember to keep that negative sign here because it was not part of the x in the original function. So I'm going to have negative 4 plus 8 is positive 4. So g of 2 is equal to 5. Okay? So that's my first one. Let me come down here and I'll do g of t in blue. So g of t really just means instead of x, I'm putting in t. And so as I do g of t, go back up here to my original that I made with the blanks. I got negative and then t squared plus 4t, just really substituting in to those blanks. And then I'm going to clean this up. So I've got negative t squared plus 4t plus 1 there. Okay? And remember, of course, that negative does not, it's not a negative t that's going in there. It's a negative times the t squared. I'll go back to this color black over here because when I'm putting in x plus 2, I've still got to put it into these blanks. And so g of x plus 2 is going to be equal to minus x plus 2 squared plus 4 times x plus 2 plus 1. Well, that's not a finished product because I have to actually do this. I have to do this operation. And so as I work on this, I've got to do minus, and then x plus 2 squared would be x squared plus 4x plus 4. I foiled that out. That's a perfect square polynomial. Okay? And so then I've got plus 4x plus 8. So I distributed here. Plus 1, and I'm just going to keep cleaning up. Got to distribute this negative in to each of these pieces. And so I've got negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. Continue to clean up. So now this goes away and this goes away. And so I've got minus x squared plus 4 plus 1, could have simplified that further, minus x squared plus 5 is my final answer on that. And so g of x plus 2 is equal to minus x squared plus 5. Okay, so I can also put in an expression, that x plus 2, into that function. Okay, so be aware that is a possibility. Let's do one more. Piecewise defined function. Piecewise defined function has two parts. It's conditional. So if x is less than 0, this is going to be the function that I use. And if x is greater than or equal to 0, this is the function I'm going to use. They tell me to evaluate the function on these three parts. And so what I need to do is define where do the pieces go. Well, if x is less than 0, that's going to go into this one. So negative 1 is less than 0, so that's going to go up here. If it's greater than or equal to 0, it's got to go down to this function. And so I'm going to evaluate each of those 3 points, but they're each going to be at a different part of the function. And so when I do f of negative 1, that's going to be equal to x squared plus 1. Well, I guess I should just put it in to make it less confusing. So it's going to be f of negative 1 means negative 1 squared plus 1 equals 1 plus 1 equals 2. Okay, so that was me putting a negative 1 to this, top one because my domain was determined to be when x is less than 0. The other two are going into this bottom one, so f of 0 is going to be equal to 0 minus 1, which is equal to negative 1. And then f of 1, still greater than 0, is 1 minus 1, which is 0. Okay, and so that's how we determine a piecewise function. We determine which part of the function each of the domain members is going to go into, and then we determine the range. All right? Very last part. Implied domain of a function. We've done this before, but this is really what can go in. But the implied part is what can't go in. Okay? And so when we see something that's, like I want to start with b here. We've got this denominator of x plus 5. We know that it can't be 0. Okay? And so x, when we say this, what we're doing is we're going to be saying x is everything but what it can't be. So x is all reals x not equal to negative 5. Okay? And so that's kind of the game of an implied domain, like what can't it be? And so when I look back to A now, let's look at A. This is a case where they only give us so many things. And so my domain is just everything that goes in. So my domain is -3, -1, 0, 2, and 4. It's what goes in. And so there's two parts to this. One, they could give you a list of values that says, hey, what is actually going in? They show us what's actually going in. Or we could use it to imply, hey, it's everything except these things. When we look at the volume of a sphere, it can seem like, well, the domain would be everything. But think about a sphere. If I've got a sphere here, and it's like this, what couldn't the radius be? Okay, and so that's kind of what we have to think of, like what could be excluded. So R is all reals, seemingly. But if it's all reals, then it's really something where it just can't be negative. So it's all reals greater than 0. It has to be. So R has to be greater than 0, because if R was less than 0, we'd have some radius that was a negative number. That doesn't really make any sense. Okay? Over here. This one's kind of a tricky one. But really what we need to do is we need to say 4 minus x squared is greater than or equal to 0. Because I can't put a negative in here. We don't want to deal in i's right now, okay, because this would be like what would be on the graph. And so I want this to be greater than 0. Well, that means that minus x squared has to be greater than or equal to 4. Okay, and so what that means is if I'm looking at this, x has got to be between -2 and 2. Because if I'm squaring either one of those, then that would mean that it's going to work out in my favor. So I'm going to have a case where this inside part is going to be greater than 0, because if I square it, either -2 or 2, then it's going to work out to where it's bigger than 0. But if it was like 3 squared, then that would be equal to 9. Well, 4 minus 9 is -5, so that wouldn't work out. So it's got to be in this interval here. Okay, so figuring out the domain of the function is something where it's sometimes easier to figure out what's excluded and then say everything else is included. All right, that's the basics of functions, guys. Thanks for watching, and we'll see you next time.